pause for a second to take a look at what's happening in terms of processing power. I have this chart there that takes a relative look at what CPU speed is. A cycle in a gigahertz computer represents electricity moving less than a meter. And it's very difficult for our minds to comprehend this. So let's pretend that 1 gigahertz is a second. So if you take a look at that, you'll see that to access level 1 cache, which is memory on the chip, it takes 3 seconds. Main memory, it takes about 6 minutes. But the big transformation that's occurred in the last few years is what's happened in terms of disk. Is that rotational disk, which was the norm 10 years ago, takes about 6 months to access, and solid state disk takes about 3 days to access. So it's a heck of a lot faster than it used to be. And so what is happening is that the blockchain has demanded a competition of very simple mathematical solutions to come up with a mathematical solution to a relatively simple problem. And to do that, the best approach is massive parallelism. And so ironically, what blockchain has done is it's driven computing from the processors, say the 3 or 5 or 7 or 9 processors on the Intel A3, A5, A7 chips to the thousands of GPUs that you find on a particular graphics card. So Moore's law is no longer relevant, is that the increase in terms of computer power and throughput that's occurred over the last 5 years is orders of magnitude, much faster than Moore's law had predicted, and I think much faster than most people expected. And to a great degree, the change in computing architecture towards massive parallelism that is driving artificial intelligence today is also what has driven mining within the blockchain. So there are 3 interrelated concepts, technologies that are driving the world today. Is the blockchain and cryptocurrencies have forced advances in hardware that allows artificial intelligence to now start eating big data in a meaningful way. So as we know, Bitcoin, Ethereum, and other cryptos for proof of work mining consume more energy now than, say, Ireland, to the point that 17-year-old Greta Thunberg has identified proof of work crypto systems as a significant global warming threat. As we know, computers worldwide are competing to mine the next block and win some crypto and write the next block in the immutable ledger. As history has shown in technology, the solution to today's problem invariably creates the next. And in the context of what's occurring with blockchain, this is indeed true. So demonstrated here is the creation of one blockchain, Ethereum 2.0, which launched on December 1st, or Beacon Chain, and addressing the current problem of energy abuse will be creating hundreds, if not thousands, of parallel blockchains that will solve today's throughput problem, and by implementing a proof of stake as opposed to a proof of work architecture, will solve the energy problem and, of course, invariably create the next problem. On a blockchain, immutability is a great thing, but immutability is also a double-edged sword. I don't know how many times in the middle of the night for different banks I had to come in and fix the systems, invariably by some corruption that occurred within the data. And the good thing about blockchains is the data is immutable. And the bad things about blockchain is that if you get bad data into the database, it's impossible to remove. Remember the DAO. So there's some challenges in the context of implementing the next generation of blockchains. I don't think that it's possible to talk about anything that's occurring in the world today without some mention of COVID. COVID is devastating the world. And to me, what is surprising about it is that the stock markets around the world are reacting positively while the people in the lower echelons of society are simply being devastated. And I find that aspirations of what the blockchain may do hopefully can possibly address some of the great inequalities that are being created today. So if you take a look at the markets in terms of what's happening, you'll see that stocks in 2020 have just skyrocketed. At a glance, NVIDIA is up 150%, and NVIDIA started to rise because its parallel graphics architecture was perfect for mining for cryptocurrencies. Amazon, not surprisingly, is up 80%. Netflix, when people are stuck at home, is also up 66%, and not surprisingly, United Airlines is down 44%. The surprise to me here is that AMD, which now produces better, faster, and cheaper chips than Intel, is up 135%, while Intel itself is down 11%. How quickly the mighty have fallen. The other surprise that I didn't chart here is Tesla this year is up a whopping 800%. So that Tesla's market cap is now more than Toyota, Volkswagen, and Honda combined. Tesla sells less than $400,000 a year, while Toyota and Volkswagen sell over 10 million each a year. We are in some very strange times. Now, if we take a look at what has happened to crypto in 2020, I don't know how well you can see the colors on the graph, so I put some of the percentages in the middle to demonstrate that in the last year, crypto has outperformed almost every stock in these uncertain times. Surprisingly, it's even outperformed gold. If you take a look at it, you say, oh my God, Chainlink was up over 500%, Bitcoin 150%, Ethereum close to 300%, and so on. And at first glance, you say, wow, look at the numbers here. Cardano up 300%, Chainlink up 473%. You can say, my God, what a year for crypto. But I think in the long view, you have to look at it in context. And the context of that is that from their all-time highs, every major cryptocurrency is down. So bottom line, crypto is still insanely speculative. It goes up and down like a yo-yo. So if you take a look at what is happening in different countries, you'll see that in countries that have unstable currencies, that crypto is increasing in popularity. Is that although to us in countries with relatively stable currencies, crypto seems wildly speculative, but for countries like in Argentina, where the peso has gone from 13 cents to the dollar, or sorry, 13 pesos to the dollar, to 82 pesos to the dollar, is that crypto is relatively unspeculative. So to some, cryptos are highly stable. To others, they are obviously unstable. But if you take a look at blockchain, the reality of what's going on here is that Bitcoin, which originally had many aspirations, but a max of 7 transactions a second, was unable to do much more than aspire new ideas. And Ethernet, which peaks out at about 15 transactions a second, both of which are limited for the vast majority of applications. As a variety of many banking, telecom, and aviation systems, I would have trouble personally trying to develop a system that would fail if it went to, say, 17 or 18 transactions a second. In banking and telecom, they're typically in the thousands per second. Now, the one that can achieve high volumes is XRP. but I suspect that many CIOs of financial institutions that implemented this technology for foreign exchange are no longer with the firm, for the simple reason that although it's up recently, it's from its initial height, it's down 85%. Its aspirations was to become the norm for foreign exchange, to undo Bretton Woods and the current predominance of the US dollar for foreign exchange. But that simply didn't happen. And most of what is occurring in terms of cryptocurrencies is simply speculation. Now, in terms of developing real applications on blockchains, one has to be aware of what Brewers Cap Theorem is. So on the right of this chart are relational databases such as SQL Server, Oracle, or PostgreSQL. On the top, you have what are called base databases. And on the left, they're base databases. And I'll get into this in a second. Each base is a base-based database that has an architecture with a single point of failure, while Cassandra has a masterless one. But basically what the CAP theorem states, that it's impossible for a distributed database to simultaneously provide more than 2 out of the following 3 guarantees. C is for consistency, like the C in ACID in SQL databases. A is in availability, in that to achieve 100% availability, and to be partition tolerance, and that is, in effect, to have no single point or node of failure. So to be a little more specific, if you take a look at these ERC20 based tokens, in technology, the solution to today's problem almost invariably creates the next. So many crypto assets are based on what is in effect the gold standard of ERC20. ERC stands for Ethereum Request for Comment, and 20 is the proposal identifier. But this de facto standard has a serious problem that it can lose a validated transaction. This fact is almost never mentioned, but by their design, they can and will drop validated transactions. In the literature, it is typically defined as time to finality. For example, Ethereum will achieve finality in likely a couple of minutes, and blockchain likely in about an hour, before you can be 100% sure that your validated transaction is deep enough in the ledger not to be forgotten on a shorter sidechain. So if I can give a really simple example of this, if you have a distributed ledger, and here in Canada, let's say the databases throughout the world are the same. And here in Canada, I want to take 20 whatever crypto out of a particular blockchain, and concurrently somebody wants to take 20 out of the same account, in effect, in India. And by definition, when the information is propagated between the databases, and I only had 25 in my account, by definition, one of those 2 transactions has to be rejected. Now, I'm not saying this is a showstopper, but in the context of designing serious systems, is that you have to accept and manage and hedge the risk that a validated transaction may be dropped from the database. So you either have to mitigate that risk or you have to accept it. And I think in the context of many applications out there, it has been accepted. Now, if I can go back a long time, I'd like to do an analogy. And I was working for Citibank in 1982, and I got a phone call from New York to come down to New York, and we'd told that Walter Wriston, the CEO of the company, had decided that we were no longer a financial institution, that we were an IT company and not really a bank. And to make his point, he'd bought a transponder on Westar 5 so that we could have near instant communication across the Atlantic. And then we called a meeting to see what the heck we would do with the satellite. So the first opportunity was pretty obvious, and that is, say, IBM stock was traded in multiple exchanges. And depending on what the exchange rates were at that particular second and what the prices were on the stock markets at that particular second, there were clearly arbitrage opportunities. So the first thing we did is we leveraged the arbitrage opportunities. The second thing we came up was with the idea that what we could do for large multinational corporations, typically American, is we could give them real-time visibility to all the accounts in all the different countries. So we spent years developing this particular application. And although we would be losing foreign exchange revenue if the subsidiary of the company was long pounds in England and short euros in India, and conversely had the opposite effect in other different countries, what we would be able to do is allow the institution to transfer money between the accounts internally without going through our foreign exchange desk or us getting fees. And we were so convinced that this powerful utility, if given to multinational corporations, would be such that the better managed financially, they would put all their accounts into Citibank. So I remember flying over to Paris and meeting the CFO of the subsidiary of an American car company and demonstrating what the system would do. And he immediately told us that if we implemented this system, he would immediately move all of his funds out of Citibank. And we sat there stunned. We were giving them a super powerful utility, and he said he'd stop doing business with us. And what we learned is that once a quarter, he flew to Detroit, and he had a chance to look at his numbers, understand them, massage them, and present them. And the thought that he would give Detroit real-time access to his accounts was something that was simply untenable to him. And the point I'm trying to make here is that you can find a great technology, and obviously there are thousands of satellites up there. It's a very useful technology. But when you start with the technology and then look for the business problem, it's very easy to miss it. So let's take a look at what the hype cycle from Gartner. I don't know if you've seen these charts, but Gartner believes that technologies simply go through a period of innovation to a peak of inflated expectations, to a trough of disillusionment, to a slope of enlightenment, to a plateau of eventual productivity. So what they argued in 2018 that with blockchain was slipping into the period of the trough of disillusionment, and it would be 5 to 10 years before it was effectively and productively used. So if we take a look at what they said recently, we're so deep in the trough of disillusionment in terms of implementing applications that it's not even mentioned on this chart. There are some interesting technologies that are evolving. Carbon-based transistors, unlike silicon-based transistors, don't require heat to create them. So in effect, unlike the chips today, with carbon-based transistors, you may be able to create three-dimensional chips. And given we've moved from a transistor first discovered in 1948, about the size of a fingernail, to 171 million transistors per cubic millimeter, is that the advances in terms of computer speed that are upon us today are likely going to continue. So let's take a look at some of the more interesting and more relevant technologies out there today. Ethereum is simply defined as a global open source program for decentralized applications. About half of the crypto coins out there run on the Ethereum network, even the tethered ones. In 2017, CryptoKitties overwhelmed the Ethereum network, and many transactions were lost. And that, if you're developing serious production financial applications, a technology that loses transactions is one you have to be very nervous about. Ethereum 2.0, which the initial phase one of it was launched on December 1st, or Serenity as they codenamed it, is a transition from a proof of work to a proof of stake architecture that, among other things, hopes to address the power consumption issue and the throughput issues. Genesis, the next phase, will be triggered when 16,032 ETH deposits are moved over to the new network, where they'll be frozen for a significant period of time, but they will receive interest and more ETH. The rate of the interest will depend on the participation. If it's a large participation, the interest rate will be lower. If there's lower participation, the interest rate will be higher. The new architecture basically is to have many multiple concurrent blockchains with a central beacon chain that will manage the other chains called shard chains. The architecture is not yet to be finalized, but in my mind, based on my experience in terms of banking, I think of it as central banks and basically a clearing system. So today's ETH will not be the central chain, it will become one of the shards. So Beacon will keep them all in sync, or in my mind, in my linguistics, it'll clear transactions between them. It'll be redefined as a super highway for Ethereum tokens. Anyway, so the idea is that you can still make money, but not mining for Ethereum. You can be a validator, and proof of stake, you have to, in effect, put on the line in terms of acting as a particular validator. So like some cryptos out there, they're not going to be 20 nodes validating what's occurring on there. They're talking potentially about 262,000 validators on 64 shards, although the number of shards could go much higher than that. So in this new paradigm, you can still earn Ether from Ether as opposed to mining for Ether by being a validated node. Whether or not this will decrease or increase the value of ETH is yet to be determined. So AAVE is the word in Finnish for ghost. It's an open source, non-custodial liquidity protocol for earning interest on crypto deposits and borrowing assets. In the last year, it has gone from 36 cents to a high of over $90. It's based on ERC20 or Ethereum. What happened is in January, it shifted from a decentralized peer-to-peer lending model to a pool-based strategy. It allows users to create their own decentralized money markets. So the AAVE protocol, depositors provide liquidity by depositing cryptocurrencies into lending pools, which will allow them to earn interest by lending. Meanwhile, borrowers can obtain loans by tapping into these lending pools in either an over-collateralized or under-collateralized way. So in effect, AAVE has become a crypto bank, which does what banks do in terms of mitigating risk by spreading it over a large number of borrowers. So effectively what AAVE is becoming is a crypto bank with depositors and borrowers without the bank. Polkadot has got a lot of attention recently. As a Web3 Foundation project, Polkadot allows developers to build and join blockchains together, facilitating cross-chain communication by connecting different blockchains onto one unified network. The one advantage of it and Polkadot and Cosmos is that they both can ensure finality. With Ethereum and with blockchain, is that if there are, say, 7 or 8 or 9 blocks that have been built after your transaction, you can be pretty sure that that transaction is immutable. But theoretically, there could be a longer chain out there that could come and erase what you're doing. So what Polkadot and Cosmos do, among other things, is they ensure finality. And to me, what is very cute about Polkadot is they have a couple of protocols. One they call Grandpa, Ghost-Based Recursive Ancestor Deriving Prefix Agreement, which is basically their finality gadget, and AAVE, which they have acronymed as the Blind Assignment for Blockchain Extension, and that's the block production mechanism. What's notable and interesting about Grandpa is it reaches agreement on chains rather than on blocks. So that speeds up the finality process. Okay, to me, another one of interest is Cosmos, which is a recent development. And once again, it's another network connecting many independent blockchains. It describes as zones. The zones are powered by open source Tendermint Core, a high performance, consistent, secure, Byzantine fault tolerant consensus model. The primary zone on Cosmos is called the Cosmos Hub. The Cosmos Hub is a multi-asset proof of stake cryptocurrency system with a native token called Atoms. The hub and zones of the Cosmos network communicate with each other via an Internet Blockchain Protocol, or IBC, which can be metaphorically thought of as a TPC for blockchains, so Cosmos claims. Inter-blockchain zone token transfers can go through the Cosmos Hub, which keeps track of the total amount of tokens held by each zone. At the high level, Cosmos is a secured protocol in place for many blockchains to securely send and receive transactions and messages to each other via the Cosmos zone. And to me, one of the big questions, and I'll get into this a little bit later, is why are there so many blockchains? Is there a really need out there for 1,000 blockchains? Chainlink is another one that is of great interest to me, like Cosmos and Polkadot. Not just the fact it's gone up 100% in the last year, but like Cosmos and Polkadot, they're middleware. It standardizes and validates smart contract inputs and outputs. So it's a general purpose framework for building decentralized networks that give you smart contract access in a secure and reliable way through its data inputs and outputs. Each decentralized Oracle network consists of a collection of independent node operators, a method for aggregating data, and pre-made chain links that act as middleware to give you access to any API you want to leverage for data or external purposes. So what Chainlink does is it simplifies, obviously, access to the blockchain, and it also simplifies access to other data sources that can derive events and smart contracts. So for instance, let's take, I don't have a good Indian example, but let's take California. And there, say you can't buy fire insurance. However, you might be able to set up some insurance product without actuators, without adjusters, without salespeople on a blockchain that if your particular zone from a satellite perspective is burned, that you get paid. Now, obviously, people who buy this insurance without the insurance companies may not get the kind of return that an insurance company would guarantee, i.e. the price or the value of their property. But if your house burns down and you have some insurance, I don't know, say $50,000 or $60,000 that would help you get settled on your feet, as opposed to being left homeless, there may be some possibilities in terms of doing it. So to me, I find this technology interesting in the context of it simplifies the creation of smart contracts based on external data, as well as what's happening on the blockchain. So there are obviously blockchains without cryptocurrencies without the problems you run into in terms of finality that you run into with proof of work or proof of stake systems. Corda is an open source blockchain project designed for peer-to-peer business. Originally, it had JP Morgan Chase, Goldman Sachs, Morgan Stanley, the National Australia Bank, and a whole bunch of others involved in it, and they pulled out. But nevertheless, they were able to develop industrial strength software that is the only blockchain that the IEEE has given its stamp of approval and resulting credibility to this blockchain. The other major blockchain that is evolving is industrial strength, can manage high volumes, and is something that is outside of the crypto space. But in terms of much of the potential of what blockchains can do, it's a very solid piece of software. And I believe I saw Brian Bellendorf on the list of speakers, so he obviously can speak to this far better than I can. But Hyperledger is a technology that originally, some of it came from Fabric, if I remember correctly, came from IBM. And Indy came from Intel, but it has developed into a strong industrial strength suite of products that recently have included Caliper, its performance benchmark tool, Cello, for on-demand deployment of blockchains as a service, Composer to simplify developing blockchain networks, smart contracts, and so on and so on. So in terms of what's happening in the world, it's most disconcerting in the context of what this virus is doing to those whose skills are deployed outside the context of a virtual office. And it's most disconcerting. The rich seem to be getting richer, and the middle class and the poor seem to be getting wiped out. So to me, it's interesting to look back at some of the perspectives of different economists in the context of what's happening. So Keynes, of which the majority of central banks are still tenants, argued that capitalism is the astonishing belief that the most wickedest of men will do the most wickedest of things for the greatest good of everyone. Milton Friedman, who believed that markets were the best solution to everything. If Central Park in New York should be a park or it should be condos, let the markets decide. Public schools, that's silly. Let the markets create schools and compete for students. So Milton Friedman was a philosopher and an economist who believed that markets solved everything. And he argued that a society that puts equality before freedom will get neither. A society that puts freedom before equality will get a high degree of both. What is interesting to me is there was a fringe theory of economics that basically argued that government spending money, government spending a lot of money, is fundamentally a good thing. And it has had different names over the decades, but it's currently called modern monetary theory, which believes that government deficits are okay, that they should be used extensively to grow to the economy to its full capacity, enrich the private sector, eliminate unemployment, give free college, support green energy, that they believe that a large government deficit in reality reflects a large private sector surplus. So basically, MMT, which in the United States is best represented by AOC, believes that large government deficits, if they don't cause inflation, and at the moment it would appear that we are in deflationary times, is fundamentally a good thing. So whether or not the blockchain can result in a more decentralized, equitable world that many in the movement had envisioned has yet to be determined, but I certainly hope it does happen. So the general counsel of the NSA, Glenn Gerstle, said, the unprecedented scale and pace of technological change will outstrip our ability to effectively adapt to it. That the digital revolution has the potential for pernicious effect on the very legitimacy and the stability of our government and societal structures. So, in summary, we are in a period of technological divergence where rapid new advances reacting to many other things, COVID-driven fiscal deficits, and a rejection of centralized authority are driving a plethora of blockchain innovations. In parallel, the demand and profits from proof-of-work data mining hardware for crypto are driving new generations of exponentially more powerful parallel processing architectures. These hardware advances were created for crypto. They are turning out to be perfect for the rapid advancement of deep learning and neural networks, creating systems that now, as the rock Tommy once said, that can see me, touch me, feel me, and heal me. We are living in most interesting of times. These times will call for visionaries to lead us through the most rapid societal changes that will have ever occurred. There is no doubt that blockchain will be one of the technology enabling this new future.